So, hello there. So, this is our midterm presentation in our Prog 5. So, before we proceed um, in the main discussion, the presentation is divided or split into two, which is the Tinkercad part and the Fritzing part. So, our midterm project is all about a Christmas theme song that is will be showing or by the help of LCD it will show the lyrics and by the help of the piezo it will release the sound. So the chosen song is the Rudolph and the Reindeer. So I don't know the specific title, but yeah, it is on the file by itself when we pass it. So we will proceed now to the Tinkercad part, which is the schematic and the breadboard part.
So good day. I'm Mr. Macano discussing bre- um, the breadboard and schematic diagram in Tinkercad. So here we have the schematic view in Tinkercad. So firstly we have this Arduino Uno that provides us the brain of our component, or what do you call this? Or prototype rather. So firstly, we have 5 volts. These 5 volts connects to everything here in that is the one that powers everything here in the schematic. So here in sheet one, we can see that it powers um, the LED red, the potentiometer, the piezo, two switch buttons, and here is LCD 16 by 2, the LED blue, LED green, and here is the in sheet 2 we can see that the it is also powered by um, the RGB LED. So what do we what does each pin's purpose is? So in analog zero, the purpose of it is to here connect the between potentiometer, potentiometer and the LCD. So analog pin 0, the controls in regards of the brightness and contrast of the LCD. So next, here in the LEDs, DC7 blue, DC6 green, and this D5 red. Um, D7, D6, and D5 corresponds to the specific digital pin of the Arduino Uno that connects and controls um, the respective LED. So next, in the here, so we have the piezo. Piezo is connected in digital pin 8. That controls the beat that produces the music that from a simple noise or buzz, the digital pin 8 creates a tune similar to the song Rudolph the Red-Nosed Reindeer. So that connects everything. So here is the um, push button that is the controls the D2 digital pin 2, then the next is controls the digital pin 3. So if we look here in the LCD, VC controls the power, VO controls the ground, then so on and so forth. Then here in digital 4, it controls the digital 4 pin in Arduino Uno. Then digital pin 5 controls the DB5, digital pin 6 controls DB6, then digital pin 7 controls DB7. So next is here in the LED, RGB LED, we have controls DC7, D5, and D6. So let's see in the breadboard view. So in the breadboard view, we can see that all the wires are situated here in the bottom area, so that if we conducted this in real life setting, it will be what do you call this? It will be uh, organized and clean compared to others. So let's try and start a simulation there. So you can see that there it start dot and it start to the color starts to glow as well as the LCD. So the potentiometer controls the brightness of the LCD. So that's all for for the Tinkercad. Now next we have fritzing and the schematic view presented by Mr. Gonzalez.
Okay, before we proceed to the main discussion of the PCB view and the schematic view, the fritzing, so let's differentiate first the limitation between the fritzing and the Tinkercad. So when it comes in the Tinkercad, the pros of it the created diagram or the created components or and also the program there, it can be run. Uh, while the fritzing, it has no features like that. But the Tinkercad has no PCB view, PCB view. While the Tinkercad, it does not have a PCB view. So that is the difference between the Tinkercad and the fritzing. So it depends on how the user will use these two types of software. But this too is very strong and reliable when it comes in the robotic industry. So we will now proceeding in the fritzing or the schematic diagram. So as you can see, the schematic diagram by itself has a purpose of knowing where are the connection of the components, so how the components relate from each other, and also how they function. So as you can see, these are the Arduino part, and this is our LCD part. So as you can see, the connection of it, I will not able to discuss the connection of it because Mr. Maano explained earlier the connection between the electronic components between the Arduino LCD, the LED RGB, and the three LED, and the buttons, and the potentiometer, and the piezo. So we have here, by the by the help of the schematic diagram, we will be able to view the values of the pins of each electronic components. As you can see in the LED, for example, the RBG, we will definitely know the what part is the red, what part is the blue. So when it comes to the LCD, you will be able to track or navigate the location of the DB, the DB1, the connection of the ground, and then the connection of the power supply. And then also in the piezo, as you can see, you will also see the connection of it. So you will see the importance of the schematic diagram. It will lessen your ability to navigate and also make you easier to navigate and connect the relationship between the electric components on the components that you manage to connect. So as you can see, these are our resistors and its values. We have a maximum of 220 and has a minimum of 10. And also we have the LED by itself. It has a blue, red, and green. And then for overall resistor, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 resistors. So that's all in the part of the schematic diagram. We will now proceeding on the PCB viewing that we will by the present by uh, Mr. Jerwin will now discuss the PCB part.
So for today, I'm gonna present the PCB layout that we created for our circuit board. So this PCB serves as the soft or soft copy of our PCB. So we commonly know that PCB is a physical component, although in the fetching it don't have a PCB But in the FreeSync we have PCB layout that you can make, or upon making the breadboard layout, the PCB will automatically created. You just to reroute it. So as you can see in our layout in the PCB, we have we use LCD, resistor, RGB, and LEDs and RGB, as well as the potentiometer. So as for the LEDs, we have four LEDs, including the RGB. So in the LEDs, it has its own current limiting resistor. So it means they have a resistor that limiting the current flow uh, for the visibility or for the brightness of the color. And as well as the RGB, it also has current limiting resistor in both three legs, aside from the cathode leg for the ground. So as for the potentiometer, uh, we have a potentiometer to adjust the brightness and the level of brightness of our LCDs. We can uh, see the lyrics through this potentiometer to adjust it to maximum, and to the minimum. So aside from that, we have push buttons to adjust uh, the light, or to turn off the LEDs and to turn on the LEDs. And for the other push buttons, because we have two push buttons, it's for the sound. If you push, it will turn off, and if you push it again, it will turn on. So that's the functionalities of the two push buttons. And we have also the microcontroller, or the board we use in our circuit board that supplies the power through the analog pins and digital pins that has its own. So thus we have this PCB layout to start our prototyping. So this kind of software can help us integrate our design in this website into a physical or prototype itself. So that's all for the PCB. Uh, I hope we follow this layout or wirings in our components, or in our prototype component. So I'll give it back to Mr. Yuriko for the outro.
So that's all when it comes the two categories that we earlier discussed between the Tinkercad and the FlexSync. So that's all for our discussion in our midterm presentation, along with my co-members, which is Mr. Maano and Mr. Jerwin Dalbime, and I, Mr. Gonzalez Yurico Ernichian. So that's all. Thank you for listening.